Jai Hind everyone. Myself Rekha Baghel, Assistant Professor, Computer Science and Engineering Department, Akgec Garg Engineering College, Ghaziabad. Welcome to the lecture series on software engineering. Subject code is KDS 063. In today's lecture, I am going to discuss the Halstead's software science matrix. This is the overall introduction that I will going to discuss today, and after that estimation of the efforts will be discussed. Elements of the Halstead matrix will be discussed next, and after that counting rules for C language, and I will complete this lecture with the help of some examples based on the Halstead software science matrix. So, Halstead software science matrix, what is this Halstead software science matrix? So, basically a matrix is a measurement to calculate the size or cost of the some software. So, there are different types of estimation techniques available for measuring measurement of the size, software size. So, this software size estimation can be calculated with the help of line of code, and function count and Halstead software science matrix. So, basically line of code, first method is line of code. So, line of code is just like just the code that is represented, that is developed for particular software, and we calculate the particular lines of a code, and after calculating the lines we define the particular size of a software. If the software contains the 100 lines of particular language, that means total 100 LOC is there. Okay, so 100 lines of code is there. So, this is the simplest method for calculating the software size. But this method have several limitations. So, first limitation is whether the code is complex or simple. It contains the same, considered the code similar manner. So, it is not feasible for the softwares that contains or that contains the complex code, or the softwares that are complex in nature. So, next method is function count. So, function count, we will discuss this method in next lecture. In today's lecture, I will discuss this Halstead analysis. So, basically Halstead analysis, what is this? So, Halstead Morris Halstead in 1977 gives the some method for the measuring the size of a software in 1977. So, this method is known as Halstead software matrix. So, basically this Halstead software matrix is based on the some phenomena that any program is implemented with the help of some algorithms. So, when any program is developed with the help of some algorithm, and this algorithms is dependent on some particular elements. So, we can say these algorithms contains the elements like operators and operands. So, according to Halstead, a computer program is an implementation of an algorithms, and that considered to be a collection of tokens which can be classified as either operators or the operands. So, this is the phenomena of Halstead. So, based on these operators and operands, so these collection is known as the tokens. So, we can estimate the efforts, that can be used to develop the particular software. So, the effort that that is used for developing a particular software is dependent on the operators and operands. So, as the number of operators increases, as the number of operands increases, the size of the software will be increased. Next, estimation of the effort. So, for calculating the efforts, as I already discussed, that we need two main tokens. First is operators and second one is operands. So, these matrices are based on some number of distinct. So, for calculating we need some distinct. These operators need to be distinct in nature. Means we need to calculate this separately, how many operators are there, how many operands are there, and we find the occurrences of these operators and operands for calculating the efforts. Elements of Halstead matrix. So, Halstead gives the various types of elements for calculating the matrix. So, there are mainly 6 type of elements available, first is program length, and the program length basically considers the how many number of distinct operators and operands available, and next is vocabulary size, program volume, program label, program difficulty, and program efforts. So, these are the different elements. So, now we can focus to the elements of the Halstead matrix in detail. So, students, this is the important in respect to the equity exams. So, in exams there is a question asked like explain the Halstead software science matrix with the help of some example, or there can be a given a problem on the basis of there will be given a set of code, lines of code, and you need to calculate these elements from this code. So, I will discuss this Halstead software science matrix. You can take the help from that, and you can calculate these elements from the code. So, I will discuss in detail. So, first I will explain how we can calculate the program length and vocabulary size, program value, difficulty label, efforts. So, this is the first thing is program length. So, program length, this is the total number of operators and operands occurrences in the program. So, if we are talking about the n, that means n1 plus n2. So, this is the simple formula for calculating the program length, where n is the unique operators and n2 is the unique operands. Okay. If how we can calculate the program length? First, we find out the unique operators in a program and unique operands in a program. Then we combine these two things and we fetch this program length. So, this is the, you need to just consider this is the unique operators. If a particular operators occurred in a program in several positions, in several places, you will count it as a 1. Okay. So, this is the distinct, this is the unique operators. So, next thing is vocabulary size. Vocabulary, okay, distinct means in this n1 plus n2, this is the total number of this, and vocabulary means here we count as 1 and this is the vocabulary size. Vocabulary size means if this is suppose unique operators occurs in 5 positions. So, and unique operands occurs 6 positions. So, this is program length is n is equal to 5 plus 6 is equal to 11. Okay. in vocabulary size. So vocabulary size represents the total number of distinct operators and operands in the programs. So this is the occurrence. We calculate the occurrences of the distinct operators and operands, and this is the total number of distinct operators and operands in the programs. So there is a basic difference between these two, program length and vocabulary size, is that in this we calculate the occurrences of the distinct operators and the operands. In the vocabulary size, we count how many distinct operators are available plus how many distinct operands are available. So this is the basic difference. Program volume, what is the program volume? This is the product of the program length and the logarithms of the vocabulary size n, small n. So this is the formula, V is equal to n log n base 2. You can calculate with the help of this formula. So here n is the, what is this n? N is the total number of distinct operators and operands. And capital N, capital is the total number of occurrences of distinct operators and operands. So you can calculate with the help of this formula. So you need to remember this table. In this table, here these are the operators and these are the operands. Total N1, N2. What is this N1, N2? What is this N1, N2? N1 is the total number of occurrences of operators and N2 is the total number of occurrences of unique operands. So here N1 is small n1 and small n2. It represents the how many total unique operators are there. N2 is the how many total operands are there. So for this is important in respect to the numerical part. Whenever some numerical is given, you need to find out the particular elements of the Halstead's software science matrix. You will first calculate this table. Okay. So next is program label. So program label, we can define the program label as this is the ratio of the number of operator occurrences to the number of operands occurrences in the program. Where N1 is the number of operator occurrences and N2 is the number of operands occurrences. So this is the ratio of number of unique operators and the total number of operators in the program. So for this is the program label and this is the difficulty label. Okay. And program label, program difficulty label, and next one is program effort. So this program effort, you can calculate the program effort with the help of this, with the help of the volume, program volume and program difficulty. So this program effort can be calculated with the help of V and D, and the program effort is E is equal to V into D. We will multiply the program volume by the difficulty label. So with the help of this, you can calculate the program effort. So for calculating the this the Halstead's software science matrix, you need to follow some rules. So how so these rules work. So I will explain these rules one by one. So first rule is, whenever you have some piece of code and you are going to calculate the Halstead's software science matrix, if there is any comment, you will ignore that. So this comment will not considered for the software science matrix. So this comment will not used. So identifier, if you encountered any identifier and function declaration, that are also not considered. Okay, means yahan we can comment not considered, identifier not considered. Function definition, declaration, not considered. Okay. So these are the important points. You will, if you encountered any one of these things, you will ignore that. Next one is, if you find any variable and the constant, it will be considered as the operands. Okay. So these variables, if you find any variable, any constant, it will be considered as the operands. Next, global variables. Global variables used in different modules in the same program are counted as a multiple occurrences of the same variable. Okay. If global variable is used in different modules, it will be considered as the single variable. Yes, single variable in multiple occurrences. If you found any local variable with the same name in different functions, are counted as unique operands. Okay. If you find any local variable in multiple functions, you will consider that variable as the separate or the unique operands of each function. Okay. These are the two important points. If you find any global variable in multiple modules, you will count it as a same variable with the multiple occurrences. If you find any local variable with the same name in different functions, then you will count this local variable in different functions as the unique operators. If there is suppose there is a local variable like a, that is comes in function m1, m2 and m3. So this local variable a will be considered as three unique variable. ठीक है, unique operand, you will consider this as a 3 unique operands. Next is function calls are considered as operators. You will consider the function call as a operator. All the looping statements like do, while, for loop, all control statements like if, else are considered as operators. Okay. So all the looping constraint and control statements are considered as operators. In control construct, switch as well as case statements are considered as operators. So till now we get the information like all the variables, constants are considered as the operands. Local variable contains in different functions are considered as unique operands. If global variables, if the global variables are used by the different modules, they will be considered as the single unique variable. Okay. So this is the summary of this slide, and next is reserve words like return, default, continue, break are considered as operators. All the brackets, commas, terminators are considered as operators. Go to is counted as the operator and the label is counted as the operators. So unary and binary occurrences of plus and minus are dealt with separately. Similarly, multiplication operator is dealt with separately. So all the occurrences of these operators are dealt with the separately. In the array variables such as the array name and the index, if this is the array name and this is the index, so array name and index are considered as the operands, and the square bracket is considered as the operator. Okay. And in structure variable, struct name, member name, or struct name, member name are considered as the operators, and the arrow size are taken as the operator. So hash directives are ignored. Hash directives are means if you face any hash directive, it will be ignored. So these are the basic rules for counting the Halstead software science matrix. So next we will move to the example. So this is the simple example. Suppose you have given this code. If k is less than 2, curly braces, k is equal to 3, x is equal to x into k, and curly braces closed. So for this, first you need to find out how many operators are there and how many operands are there. So operators, if we talk about the operands, all the variables and constants, all the variables and constants are comes under the category of operands. So in this program, how many operands are there? First, k is a variable, so we write it in the category of operands k. Next, 2 is a operand. Next, k we already written here, and 3 we write here 3. Next, x is a variable, so we write in under the operand part x, and okay, so k is less than and this. So this is the, so these are the operands here, x, k, 3, 2. So these are the total operands here. If we talk about the operators, so operator is if this less than this less than part. Next, these brackets, curly braces equals to closing curly braces, semicolon, asterisk part. So these are the some operands here. So this is the way by which we can calculate the Halstead software science matrix. So next point is, next we can take the example. If this is the sample of code, if k is greater than 5, curly braces, x is equal to x plus 2. If x is less than 7 and some curly braces, x is equal to 0 and curly braces closed. From this example, we need to find out the elements of the Halstead software science matrix. So first thing that we need to calculate is the number of operators and number of operands. So from this code, we will calculate the number of operators and number of operands. So these are the number of operators. If small bracket greater than curly braces equals to, and these are the occurrences. These are the occurrences of these particular operators, and this is the part where this is the operands. These are the operands, and we will calculate the occurrences of these operands also. So now finally we calculate the total number of occurrences and total number of unique operators and operands. So this is the total number of occurrences of operators. These are the total number of occurrences of operands. These are the unique operators and these are the unique operands. So total length, total program length is n is equal to n1 plus n2, means total occurrences of operators plus total occurrences of n2, total occurrences of operands. So 15 plus 9 is equal to 24. Vocabulary size is the total number of distinct operators plus total number of distinct operands. So we will, and total number of distinct operators are 9 plus total number of distinct operands are 5. So 14. So this is the vocabulary size. Next we will move to the, what is this? This is the program volume. So program volume can be calculated with the help of this n log n1 plus n2 log n. So we can put the values of n1 and n2 here and calculate the n here. So vocabulary size, for vocabulary size we apply this formula, and with the help of this formula we can find out the total volume, total program volume. With the help of this program volume with the help of the total length and total occurrences of operators and operands, we can find out the difficulty level of the program, and effort can be calculated with the help of volume that we have calculated here and the difficulty level D. So this is the effort that can be calculated with the help of this program. So for solving the example, or for solving the numerical part on the basis of Halstead software science matrix, you need to focus on some points like how many distinct operators are there, how many distinct operands are there, how many total occurrences of the operator, how many total occurrences of the unique operators, and total occurrences of the unique operands are there. On the basis of these two things, you can calculate this program, or you can calculate this numerical or each and every elements of the Halstead software science matrix. So I hope it is clear to you how you can calculate the distinct elements of this Halstead software science matrix. In next lecture we will discuss more concepts of software engineering. Thank you.